So today we are going to design a prototype for understanding a little bit about how force sensors work. These force sensors convert mechanical forces such as pressure, tension, stress, and strain into electrical signals, giving important health parameter signals. Some sensors are used in different fields, including soft robotics, electronic skin, and wearable electronics for health monitoring and early diagnosis of diseases. So this is what we are going to do today. We are bringing this example so you can apply this prototype into your classroom. Which ones are the components we will need? So we are using Arduino Uno. So we're bringing this microcontroller. Also for the wiring, we will need a breadboard. In this case, since we are going to use different components, we will look for the large breadboard, which is this one. So we are bringing this one to the left. We will need the force sensor. This force sensor needs a resistor, so we are bringing a resistor. Also, as an alarm, we will use an LED, so we're bringing an LED. And this requires as well a resistor. So we bring the resistor there. Remove this one. All right. For displaying data, we will need an LCD. This one is a 16:2 LCD. So we are bringing to the left our LCD. And for controlling the brightness, we need a potentiometer. And for controlling the flow of the voltage, we need another resistor. And basically, we are ready for designing our project. So the first thing is going to be placing the components on the breadboard. And I'm going to start with the force sensor. Then I'm moving my LED and towards my potentiometer, and last my LCD. Just making sure here that the pins of our LCD are connected to the pins of our breadboard. So that way we are ready for the next step. Moving this a little bit to the top so we will have space for our design. The project requires 5 volt and ground. So we are going to bring 5 volts from the microcontroller to the red rail of our breadboard, which is this one. If we see here at the left, we have the positive. So all this rail is going to be positive or anode. We change the color of our cable to red, so we will identify the voltage. Next to the voltage, we have ground. In Arduino Uno, it is represented as GND. So we are bringing a cable to this section and change the color, so we will identify this as a ground. So now we're ready to connect the first component, and this one will require a resistor. So we can move this a little bit so we'll have space for flexing this one. the left pin, we're going to start with this one, requires a resistor of 100 ohms. So we are going to change the value of our resistor, and then we are moving this one to our left pin of our let's see, I will place this one to the left pin of our force sensor. We need to rotate since we are going to connect the two ends of our resistor. The first one is going to be connected to ground. So we're going to look for ground and connect. This section is another pin that will go to the analog side of our microcontroller. So I will look for A1 or analog 1. So in here I'm going to connect the second wire. We can bend this cable so we can have space for the other cables here. So like that. The second pin is going to be the 5 volt. So we're going to look for the connection to 5 volt. And again, bending the cable so we will have a better understanding where the connections are going. Our next component is going to be our LED. These LEDs require 220 ohms in a resistor. So we're going to change the value of this one to 220 ohms. So that way we can work with this resistor. We are going to move this resistor to the cathode of our LED. And if we take a look to the left pin, this one is the cathode that we are going to use for connecting the resistor to ground. So let's bring the resistor, place this one in front of cathode, connected to ground. Like that. Because the second pin is the connection to the microcontroller, which is the anode, and this one goes to the number 8 of our microcontroller. So we are going to draw a cable from here to number 8. The third connection is going to be our potentiometer. So we are going to rotate this component so it's going to be easier for us to draw the cables. So the first one is going to be a connection to our ground. So we are going to look for ground on our breadboard. Then the second connection is the signal, and this one goes to one of the pins in our LCD. So we need to look for contrast in our LCD and we will connect. If we take a look to pin number 1, this one is ground. So this is not the one we're looking for, power. So the third one is our contrast. This is the one we need for the second pin in our potentiometer. So we are drawing a cable and we connect. So we have contrast to the second pin of our potentiometer. And the next one is going to be the 5 volt for our potentiometer. And the third component connected. So now we are gonna start with the last, which is the LCD. LCD has several wires here that we will use for displaying data. So let's take a look to the first one. In here is ground. So we are going to use a connection to the blue rail on our breadboard. Second one is power. Our voltage goes to red. The third one is already connected. Then we have the first register select. This one is the first connection to the digital side of our microcontroller, and this one is for reading data. So let's place this one to the number 12 of our microcontroller. Can bend this cable so we will have enough space for the other cables and as well for seeing the connections here. I'm going to move this project a little bit to have the space for bending the cable like that. Then the next pin is going to be reading read-write. This is another connection to ground. This type of LCDs require 3 grounds. So this is the second. And connection number 6 goes to another digital side of our microcontroller. And let's place this one on number 11. We can do the same, bending the cables. So we have space for all the others coming. So like that. Now I'm gonna start with the right side. So now from right to left, since I need to test the LCD, the brightness of the LCD. So I'm gonna start with this number 12, which is LED cathode. This is gonna be connected to blue, which is here. And the second one is gonna be our anode or the positive. In here, we need to place a resistor for protecting a little bit the energy coming from the microcontroller to the LCD. So this one goes to here, and then since this one is 1 kilo ohm, is not going to be useful for our project. We need to change this one to 220 ohms. So in that case we have the resistor connected, but not ready. We need to draw another cable from here to the red rail of our breadboard. So that way we have the connection complete. So I will move my project to the top a little bit so you will see the LCD. It's time for testing the LCD to see if the brightness is there. So start the simulation, and we are going to see light on the LCD, and then we will rotate the potentiometer, and the next thing that you are going to see are the 2 rows and the 16 characters that we will need for reading data. So if this project is the LCD is working, so the next thing is gonna be the last 4 cables before the code So we stop the simulation. And let's continue with the third connection to the digital side of the microcontroller. And this one is going to the number 2. So we're drawing a cable to the number 2, digital number 2. Bending the cable so we will have space for the others right there. Next one goes to digital number 3. Next one goes to number 4. And the last one to number 5. We can move these cables so we will see the connections. Basically, our project is ready. We can use this zoom to fit, so we will have our project finished. So the next thing is gonna be the typing of our code. So in here, we are going to this section. We are using text since we are using C++. And the code that Tinkercad is providing, erase. We're gonna start including our library. So that is the first thing we have to type. And this one is gonna be the communication to our liquid crystal display or LCD. Then the integers, which is the sensor pin first, which was connected to analog one. We are going to start the force value with 0. And as well, bounce. Next thing is going to be the liquid crystal. We need to give a name to this LCD, so I will call it LCD. And we need to type the connections or the pins that we use in our microcontroller. So we started with number 12, 11, and then 5, 4, 3, and 2. We have as well an LED connected. This one is was red, so let me just so this one was red, and the connection is to number 8. Basically, those are our variables. The next step is going to be the void setup. In void setup, we are going to start the monitor, which is the serial begin, with a baud of 9600. And of course, we are going to start our LCD, the display, and this display is a 16:2. We have as well two connections, one input, one output, so we need to declare those as pin modes. So we gave the variable name here sensor pin, so sensor pin as an input. We have also red LED, so in here we're going to put red as an output. We close with a curly bracket the void setup. Now the function of our project, which is the void loop. In here we are going to type all the formulas that we will need in the printing for our display. So since we are using decimals, so we are going to use float, the function float, and the force value. And this one is going to be the reading of the analog connection, which is the sensor pin. This one is going to be represented as N for newtons. For the reading of our sensor, now the float in pounds. And this one is going to be a multiplication of the newtons times 0.224. Now we're going to start placing the cursor. This one is going to be, we're going to start displaying data in starting from the first character, the first row. First character, first row. There we are going to print force value. And then the variable, which is force value. So we will see the number that the sensor is displaying there. We will leave a space and then we are going to start typing on the second row. So in here we are placing the cursor starting from character 0, second row. There, we are going to print the word pound. Then the value of this variable. Leaving a space. And closing our void loop and the code.